This video will describe how to take one graph of a function and create another one by transforming it. The first transformation is the following. The graph of the function f of x plus c, here c is some real number, is the graph of the regular function f of x, but shifted up by c units. So for example, if I have the graph of a function on the interval from a to b as shown here, so if this is my function f of x, then the graph of f of x plus c would be shifted up by c units. So it's the same shape, but just translated up. So there's f of x plus c. Similarly, the graph of f of x plus c, here the argument of my function, what I'm plugging into the function is x plus c. This is the graph of f of x shifted to the left by c. So as an example of that, let's suppose I have a function on the interval from a to b shown here. So that's my f of x. Then on the interval from a minus c to b minus c, so I translate this to the left, I move over to the left, I have a similar picture. That's supposed to be the same function, but just shifted over a little bit to the left. Let's see some examples here. So as an example, I can graph the function x minus 3 squared. This is the graph of x squared shifted over by 3. So I know what the graph of x squared looks like. That's a basic parabola. And I'm going to move that over. Since here my c value is -3, I'm going to shift it to the left by -3 units. In other words, I'm shifting it to the right in this case. So here's 3, and I have the graph of my parabola. As another example, I can graph the function x plus 1 in absolute value minus 2. I'll do that one over here. That graph is the graph of the absolute value function shifted over. I know what the absolute value function looks like. That looks like a v. But in this case, I'm shifting the whole graph over to the left by 1 unit, and then I'm shifting the rest of the picture down by 2 units. So I'm doing both a vertical shift and a horizontal shift. That means the point of the v will be at the coordinate -1, because I'm moving to the left 1 and I'm moving down 2. So here is -2, and I draw the graph of the absolute value translated. There are other ways to transform graphs. In particular, the graph of negative f of x is the graph of f of x reflected about the x-axis. So to give you an idea of what I'm doing here, if I have the graph of a function on the interval from a to b, so let's say my function is here, there's my f of x, then I'm going to reflect this across the x-axis and try to draw the mirror image of this graph below the line x equals 0 or y equals 0. So here I would draw something that looks like that. That would be negative f of x. The graph of the function f of negative x is the graph of f of x, but this time reflected about the y-axis. So that picture might look like this. So I have a function on the interval from a to b. Maybe it's a straight line like this. I'm going to reflect that picture about the y-axis. So this will be negative a, negative b. I'm going to kind of flip this picture over and get something like this. So that would be the graph of f of negative x. Why don't we do a couple of examples of this? So why don't I graph the function negative the square root of x plus 4. So I'm doing two operations here. The first one is I'm shifting the graph horizontally. I'm shifting it to the left by 4. And after that, I'm reflecting the graph about the y-axis. So I'm starting with the square root graph and thinking about those two transformations. So I'm shifting the square root graph over by 4. So here is negative 4. The square root graph, let me put it in dotted here if you could see that on the screen. That is the square root graph, and I'm going to reflect that about the x-axis and get the actual picture looking like this. So this is the graph of the function negative square root x plus 4. Let's do another one. How about if I graph the function 1 over 1 minus x plus 1. So the base graph that I'm thinking about, the graph that I'm going to play around with is the graph of 1 over x. So if you remember the graph of 1 over x, it kind of looks like this picture. So that's the graph of 1 over x, and I'm doing a few things to it. The first thing, maybe I should write down what I'm doing here. I am going to shift the graph of 1 over x left by 1. That will give me the graph of 1 over x plus 1. Then I am reflecting about the y-axis because I'm replacing the x I see with negative x. So that would be 1 over negative x plus 1. And after I do those two moves, I'm shifting up by 1. That's this plus 1 here. So if you combine everything, I believe you'll get a picture that might look a little something like this. So I'm shifting this graph to the left by 1. Then I'm going to reflect, so it would be, the origin here would be moved to this place. But after that, I'm going to reflect about the y-axis. So I'm going to flip that over to 1. Now this origin thing is at 1. And I'm going to shift up by 1. So here I'm at the point 1, 1. That's kind of like the middle of this picture. And I've also reflected about the y-axis. So I believe I'm going to get a picture that looks something like this. All right, that was a semi-confusing example, but I hope we got it. Now there's one other kind of transformation that I'd like to discuss in this video. So let me get a new page here. And I'll tell you that the graph of c times f of x stretches the graph of f of x vertically by c. So the picture of this situation would be, I have maybe a graph on the interval from a to b that goes up and down a little bit. When I multiply by a constant c, like I multiply by 2, I'm going to stretch this graph vertically by 2 and exaggerate the up and down movements. Something like that. So that red graph could be f of cx, or c times f of x. And the last operation is the graph of f of cx stretches the graph of f of x horizontally by 1 over c. I think I'll do an example to show you the behavior of stretching the graph. Now I say stretching, if c is 2, it stretches the graph, but if c is, say, a number less than 1, like 1/2, everything will be compressed. So let's see a few examples to end this video. So why don't we graph 2 times the square root of 1 minus x squared. So if I didn't have this 2 in front, I'd have the basic shape of the top part of a circle of radius 1. But since I'm stretching vertically, I'm still going to have a domain of -1 to 1. The basic shape would be a circle of radius 1, but instead of a circle of radius 1, I'm going to stretch it out and get maybe an elliptical type shape here. And one final example, let's do an example of a horizontal stretching or compression. So why don't we graph 2x squared minus 2 times 2x plus 1. Now, what I'm doing here is I'm taking the function f of x equals to x squared minus 2x plus 1, and I'm plugging in f of 2x wherever you see an x. So the base function is what you see circled. This is the function x minus 1 squared. So that's my basic shape. My basic shape is a parabola that's shifted over to the right by 1. So I start with that. Actually, let me try to draw that dotted here. So there's 0, and there's 1. There's 2. So I'm going to try to draw a parabola that goes like this. I don't know if you could see the dotted. I hope it's dark enough for the video. But this is a parabola that's shifted over to the right 1 unit. Then I'm going to do a stretching by 1/2. So here c is equal to 2. So I'm going to stretch by 1/2, meaning I'm going to do a horizontal compression. I'm going to take this picture and I'm going to like squeeze it in. And I believe if I do that, I'm going to get a picture that's a little bit more compressed that looks like what you see here. Okay, so those are the different ways to transform graphs of functions. Wonderful.